Question number 36. It says that the driver of a car traveling with the speed of 30 meters per second towards a hill sounds a horn of a frequency 500 Hz. If the speed of the sound in air is 330 meters per second, then the frequency of the reflected sound as heard by the driver of the car. Now this is the case when this driver is approaching the hill. Now whenever you are given to find the reflected sound from the hill, so you take this hill to be a mirror, then your virtual source becomes the car, which is in mirror. What do you find? This would be in mirror, that car coming in this direction. So, and what is the horn given by this? The frequency is given, so 500 Hertz. Now what is heard by this driver is the reflected frequency. The sound is traveling from the source towards the observer, and the formula for apparent frequency is equal to real frequency, velocity of sound relative to the observer, velocity of sound relative to the source. Now n is given 500, the velocity of sound relative to observer, sound relative to observer. Now this is the observer which is moving at the speed of 30, and sound has the velocity of 330 meters per second. So this becomes 330 in the opposite direction. So add, divided by velocity of sound relative to the source, this becomes the source, and that is equal to 330 in the same direction minus 30. So the reflected frequency will be equal to 500 into 36 by 30. So cancel out, this become equal to 600 Hertz. And look at the option. The option 2 is 600 Hertz. So answer to this question is 2. The question number 37 is a semicircular wire of radius r carries a current, is placed in magnetic field B0 on the left and 2B0 on the right of y-axis as shown in the figure. The magnetic force experienced by this half wire. The wire starts from here and ends at this point. Now see, on this section the magnetic field is different value, and on this section magnetic field is of different values. So we have to take the effective length, and this would be the effective length, and this effective length will be, this is r and this is r. So the effective length will be equal to root 2 of r. Now the current is like this one, and see, magnetic field is perpendicular downward. By your Fleming's lift-and rule, you find that the force would be acting in this direction. Now look at this one. This wire has the effective length again equal to root of 2r, because this is r and this r, and magnetic field is downward, and the force will be in this direction perpendicular to this. Now see, the forces, this and this force F1 is perpendicular to F2. And how to find the net force? Net force is equal to F1 square plus F2 square, and cos of 90, that becomes 0. Not in upward direction, but the value will be this one. How will you find F1? The force is BIL, and B is equal to V0. The current is given is I, and the length is root 2 R. And what would F2? The field is 2B0. The current is I, and the effective length is root 2 R. And if fill up here, this become root 2 B0 IR, and this is 2 root 2 B0 IR. And fill up here, therefore the net force become equal to root 2 V0 IR square plus 2 root 2 B0 IR square and whole root. So 2 and 8, this become 10. So 10 means root 10. So root 10 and multiply by V0 IR will be the magnitude of the net force acting. And see, the fourth option is this one. The question number 38 says that a wire of fixed length carries a steady current if this wire is bent into a circle of 1 turn and the magnetic field at the center is B. If it is then bent into a circular loop of n turns, the magnetic field at the center. Now see, in the first case, the L is equal to 2 pi r. If it is made into n turns, the same length, then the radius will change when you make n turns. Therefore, this radius become equal to, if you comparison, that become r by n. And see, what is the formula for magnetic field? In the first case, magnetic field is equal to mu naught I divided by 2r at the center of the circular ring, and in the second case, magnetic field is equal to mu naught Ni divided by 2r. So this is mu naught Ni divided by 2, and this is equal to r by n, that is equal to n square times mu naught I divided by 2r. And this was the original magnetic field, so n square times the original magnetic field is the new. So n here given small n, so your answer become n square into b. So answer to this question is option number 2. Question number 39 is, a bar magnet of steel has a magnetic moment of 3 ampere meter square and a mass of 6 into 10 to the power minus 3 kilogram. If the density of the steel is 8 into 10 to the power 3 kg per meter cube, the intensity of magnetization of the magnet. Now dear student, what is the intensity of magnetization? That is the dipole moment induced per unit volume. And the dipole moment induced is given 3 ampere meter square, and volume is mass by density. The mass is equal to 6 into 10 to the power minus 3, and the density is given 8 into 10 to the power 3. So let's solve. So that become 4 into 10 to the power 3 into 10 to the power 3. So 4 into 10 to the power 6 ampere per meter. Look at the option. The first option is 4 into 10 to the power 6 meter. Now the question number 40 says that two resistors of resistance 10 ohm and 20 ohms and an ideal inductor of inductance 10 Henry are connected to 20 volt battery through the key as shown in the figure. The ratio of the final to the initial current on closing the key. Now dear student, when initially you switch on, then the current start rising in this one. This inductor fully block the circuit, behaves like the open circuit. So therefore the current should move through this and complete the circuit. So therefore the initial current is, the voltage is 20 and resistance of path is 10 plus 20, and that is equal to 2 by 3 ampere. Now what happens in the final case when it is fully charged? So this will behave like a short circuited, and so the current will go straight through this one, not through this. Then in the second case the current will be equal to 20 divided by path resistance, which is simply equal to 20. So final current is 1 ampere. Now ratio of the final current I prime by I, and that is equal to 1 divided by 2 by 3, and that is equal to 3 by 2. So option number 1 is the correct option.